So it's still going slower than the speed of light. So 260 plus 260 does not equal 520 in this case. So it actually is traveling across here at 37,000 kilometers per second, but to them, due to the measurement instruments having changed, it appears to be moving at 260. But in actual fact, it's not the case at all. So you might wonder, well, why isn't is it possible? Why isn't it possible to add one velocity to another like that, 260 plus 260, producing the final 520? Well, one way you can look at it is, imagine this is a baseball, and let's say you're watching a baseball game, and just when you turned over to get some food from a vendor, the baseball comes around just in front of you like this. But just when it was lined up in front of you, all time surrounding you slowed down. But you're still moving through time just as fast as you were before. And so you're looking at it, I think it's defying, from your point of view, it's defying gravity. It's just suspended there in the air. But if you look at something in the background, you notice it is moving, but very slowly, like the minute hand on a clock. And so you try to push it, but it seems to have no effect. So then you put your hands on top of it and lift your feet off the ground. And it just, you have yourself suspended in the air now, and it seems to have no effect upon it. But if you look at the background, you might see that it's slowly going down, but very slowly. But the point is, forces laid upon it have very little effect, but that's because it's in a slow time frame. So if you were trying to, let's say, grab that ball and throw it in the normal manner, from its point of view, you're throwing it at one heck of a speed because it's in a slow time frame. Or if you look at another way, let's say under normal conditions, you can stop the baseball, grab it, catch it and grab it, and it takes 1 second for you to stop it. But if you stop this one in 1 second, from its point of view, you've stopped it in almost no time at all. And that takes an enormous amount of energy to do that. So the fact that it's in a slower time frame, it simulates this idea as though its mass has increased, even though its composition hasn't changed at all. If it's going slow enough, the chance of you grabbing it and throwing it like a regular baseball, you'd have just as much ease at doing that as you would if you tried to reach for the moon and throw the moon. In other words, if you reduced its time, if it was in a slow enough time frame, that could simulate having the equivalent amount of mass of the entire moon. Or if it's even slower, it could be more, and so forth. So when you're, first of all, when you're whipping across space at 260, you and the gun and so forth, you're already moving through time at half speed. I am going to fire the gun now, and so forth. And so, and then, as the bullet starts moving faster, let's say this is the shaft of the gun. As the bullet starts moving faster and faster down the shaft due to the exploding gunpowder or whatever they use, the expanding gases are pushing the bullet. But the faster the bullet goes, the slower it's moving across time. So it's in a slower time frame. Thus, the effectiveness of the gas, expanding gas, is having less and less effect. Now, it's becoming less and less as far as pushing the bullet goes. And so by the time the bullet comes out at the end of the barrel, it's only moving at 37,000 kilometers per second, not 260. Now, if you do a little bit of math, instead of taking lengths and so forth into that calculation of this speed and so forth, you can actually reduce it down to simply using velocities. The velocity of the bullet and the velocity of the spaceship. So this velocity of the spaceship, we'll call that v, and the velocity of the bullet, we'll call that u. And so what we come up with is an equation u prime plus v over 1 plus u prime v over c squared, and that equals u. So here you have u prime, that's the speed of the bullet as they see it. So you have 260 plus the velocity of the spaceship, which is 260, divided by this gives you the result of 297,000 kilometers per second. So that's your velocity addition equation, is basically what that becomes. Or you can reverse this as well to change it around, sort of like a transformation. So you could change this to just u. This becomes minus, this also here becomes minus, that becomes just u as seen by the external observer, and this becomes your u prime. So that would be, in this case, 297,000 kilometers minus the 260 divided by this, which would give you 260. In other words, the speed of the bullet as they see it. So just by using this simple ABC geometry, what we come up with is these equations. We have all of them here, all matched up. In fact, let's clean this up. And slide this over. So there we have, again, we calculated all of these equations just using common sense to produce them. Now, some of the people I've presented this to say it's a load of rubbish, because they say, well, Albert's special relativity basically says that everything is just relative, right? And but you, to create your equations, related a body at rest to a body in motion. But according to relativity, you can't really tell you if you're at rest, so there's no such thing as truly being at rest. Neither one nor another body, one relating to another, is truly at rest. One's in motion relative to the other, this one's in motion relative to this one, and vice versa. You know, there is no at rest. Therefore, your method of deriving these equations is total rubbish, even though it produced the exact same equations. And the method, by the way, that I've derived these equations is so simple that you don't even have to go out and purchase a deriving license. And it's the simplest method possible, and that's why you won't find this in the physics books. You won't find it on the internet, except for on my own personal website. It's the simplest way possible, done by simply analyzing motion. But anyway, they weren't too smart to say that it was a load of rubbish, because they weren't thinking very clearly, obviously. Because let's say these are two identical spaceships. This one knows exactly what's going on over here based upon these equations, as we've made clear. However, if this guy decided to go in this direction, what happens? This happens. The clocks are no longer synchronized. The clocks have slowed down. The rulers have shrunk. So all of his measurement instruments have been affected. So immediately when you move away from being at rest, that's automatically compensated for. As a result, if he's going, let's say, in this direction, he can know exactly what's going on over here by using the equations, meaning the equations are still 100% valid. Because if he moves away from here, he's not in the same condition as he was when he was at rest. His measurement instruments have also changed accordingly. And therefore, the equations are valid between a moving body and another moving body, which is moving faster, or a stationary body and a moving body. Therefore, since the equations are valid in both cases, you can't tell if one of them is at rest or not. But that obviously doesn't mean that there's no such thing as being at rest, because I've used from being at rest all the way up to the maximum speed possible across space. In other words, looking at the big picture, one extreme and the other, from one extreme minimum to the maximum, so forth, which ends up producing these equations and making it crystal clear as to why these equations are produced by showing you how measurement instruments are changing. It's that simple. So to say this is total rubbish, and even though it produces the same equations, again, people are just not thinking very clearly, because basically they're caught up in circular reasoning. They can't extend the mind to the absolute. Because when they say that, well, everything's just relative, therefore, if you take your view and extend it to the complete, the absolute, the big picture, then you see the absolute foundation which creates these relativistic-like circumstances. But if you just accept that everything is relative, then you're not willing to back off or expand your awareness to see the complete picture or the absolute picture, such that you can see the cause of what makes things seem to be relative. Anyway, so moving on from here, we'll go one step further to show other things which make it seem like everything is relative based upon these circumstances. And we'll deal with two twin spaceships, this one and this one. And we'll have this one down here being at rest and the other one moving across at our usual 260, and show you some fascinating things of how it makes it seem like everything is just relative, even more. Okay, moving on.